Hey guys, I'm Mr. Bohoric, and today I want to talk about linear inequalities. So what I've got here is basically what looks like a y equals mx plus b. Okay, it looks kind of similar like that, slope-intercept form, but instead of an equal sign, we've got an inequality. So let's take a look at what is going to happen when I try to graph this thing. So remember, on an equation, okay, on an equation, all the solutions are ordered pairs that you can plug in to make it true. Well, that holds true for inequalities as well. It's all the ordered pairs I can plug into this statement, and it's a true statement. So you'll see that it'll end up looking a little bit different than what you're used to once you actually graph this thing. So one great thing about linear inequalities is you kind of graph them in the exact same way. So you solve for y first if you want to get it in slope-intercept form. And then we're going to just graph it like normal. We're going to use the y-intercept, 1, and we're going to use the slope, 2, to make a line. So let's go ahead and do that. So the y-intercept is 1, and the slope is up 2 over 1, so up 2 over 1. Now, before you draw your line, be careful here. Now we have to do something a little bit different. You'll notice that it's greater than or equal to. So what we do with this, kind of similar to how when you graph inequalities before on a number line, remember how it was like an open circle, or maybe it was a closed circle like this? Well, since it has the or equal to, that relates to the closed circle one. It's shaded in one, so closed. So we actually draw this as a solid line. If it was an open circle, if it didn't have an or equal to, which I'll do an example to in a minute, if it doesn't have that, it would be a dashed line. So this one is going to be a solid line. So I'll draw it in magenta. I'm telling you, it's really not that easy drawing lines out here. Well, we're not quite done yet, okay, because we want to represent all the points that we can actually plug into this inequality and have it be an actual solution. So we need to actually shade one side of the graph. Just like how on these number lines you got to like shade to the right or maybe to the left, we have to do that on the graph as well. So we're going to need to shade all of the y values that are larger than this line. Okay, well, I like to look at the y-axis to kind of see where that is. Well, the y values that are larger than the line are the ones that are above the line. So I want to shade everything above the line. You kind of think of the line as kind of like a slide or a staircase, and I shade above the staircase. So I'm shading everything, like literally everything above this line. And that's my answer. That represents all of the points that I can plug in and have a true statement. I can plug them in all the way up to the line, and I can plug in points on the line, but I can't go on the right side or the underneath the line. That won't work. So let's actually test out some points to see what happens. So I'm noticing that one point that is not on the right side is, let's say, how about 1, 0? That's an easy point to pick right there. So let's try plugging it into our inequality and seeing if it works. It shouldn't work because that's not on the shaded side. So let's test it out though. So our point was 1, 0, so that means y is 0. 0 is greater than or equal to, and x is 1. So 2 times 1 plus 1. So 2 times 1 is 2, and 2 plus 1 is 3. So is 0 greater than or equal to 3? No! Okay. So that means at this point, 1, 0, that's not a solution. And that makes sense because it's not on the side where we shaded all the solutions. Let's test to make sure that we shaded on the right side. How about the point -2 and 2? So we're going to test out the point -2 and 2. And this should be a solution because it's on the side where we shaded. All right, so y is 2 greater than or equal to 2 times -2 plus 1. Well, 2 times -2 is -4, plus 1 is -3. So is 2 greater than or equal to -3? Yes. Yes, it is. So that means that that is a solution. You could even plug in points on the line itself. So how about I'm just going to plug in the y-intercept. Okay, 0, 2. And again, this should work. The y value is 2 greater than or equal to 2 times 0, that's the x value, plus 1. So 2 times 0 is, well, 0. And then 0 plus 1 is 1. So 2 is greater than or equal to 1. Hooray! means it is a solution. So that means points on the line itself can work as well. And that was graphing a linear inequality. Now, I just want to graph a few more of these so you can see a couple good examples of these. And then maybe I'll make another video on how to kind of set up word problems with these. Yeah, I think 2 videos would be better for this because I don't want to be too long. So let's erase all this stuff. Awesome. And we'll do a whole new equation. I'm sorry, I said equation, inequality. So how about y is less than negative 1/2 x plus 4? Then I'm just making these up off the top of my head. So we'll find out what it looks like. So here's a good graph, and let's see what it looks like. So it's already solved for y, so I don't need to do anything as far as like moving stuff around on both sides. Okay, so let's find the y-intercept. Looks like it's 4. 4 from right here. And the slope is negative 1/2, so I'm going to go down 1 over 2. I'll do that again so maybe I can draw a little bit straighter line on this tablet. Now before I draw my line though, okay, be careful. I want to make sure I draw a solid or dashed line. So I don't see an or equal to, so it must be a dashed line. So I want to draw like a slash line going through those points. That should do pretty well. Okay, and that means that I can't plug in points on the line, and I'll show you a test of that in just a second. So let's actually do our shading now. It says y is less than, okay, less than this line. The y values we're interested in is less than that line. So I look at the y-axis and I say, okay, where are the y values that are smaller than or underneath the line? Well, that's down here. Okay, it's these guys. So I'm going to shade underneath this line. All right, and there's my pretty magenta shading. And so what does this represent? Well, all the shading represents all the solutions, all the ordered pairs I can plug into that inequality and get a true statement. If I try to plug anything in on the other side, okay, well then I'll get an untrue statement. It won't make sense. And I can't plug in things on the line. I can't do that. It won't make sense. And I'll test that out. Let's plug in the y-intercept. That's on the line, isn't it? 0, 4. And you'll see that it won't make sense when I plug that in. So y is 4 less than negative 1/2 times 0 plus 4. Well, negative 1/2 times 0 is just 0, and 0 plus 4 is 4. Now, I got something that doesn't really make sense here. So 4 is not less than 4. 4 is 4. So that doesn't work. No, it doesn't work at all. So that means that we can plug in points that come all the way up to the line, but we can't plug in points that are on it. Okay, we can't plug in any points that are on the line. Well, we could plug them in, but they just won't be a true statement. So we actually can call this, we call it a boundary line. You may have a math teacher that calls it that. It's called the boundary line. I just call it the line, but it's typically called the boundary line. So that's a linear inequality with a dashed line, and this one's shaded underneath. Now I just want to do 2 more, okay, and these are just special ones, just so I can kind of point them out and not forget about them. So let me erase all this. We're going to have 2 graphs this time, because we're going to do 2 really short ones. Alrighty. So let's have, how about y is less than negative 2, and then we'll have x is greater than 4. All right, so I need 2 graphs this time. So here's one, here's one. And let's see, how about this bright blue right here? Okay, so y is less than 2. Well, if I had y equals negative 2, that's just a horizontal line through negative 2 on the y-axis. Well, if it's an inequality, check what type of line that is. Well, there's no or equal to, so it's a dashed line that's horizontal through that number. So it's pretty much the same thing. It's just we have to check whether or not it's a solid or dashed line. So it's a dashed horizontal line. And we still have to shade. I'm looking at the y values that are smaller than negative 2. So look at the y-axis. Where are the numbers that are smaller than negative 2? Well, that's underneath the line. So I want to shade under the line. Cool. So that would be what the graph looks like. Now, this is the only one that's kind of different. If I had something like x is greater than 4, okay, x is greater than 4. Well, if I had x equals 4, it's a vertical line through 4 on the x-axis. So before I draw my line, okay, I want to just double check to make sure it's solid or dashed. So this is going to be a dashed line because I don't see an or equal to. Remember, if it's an or equal to, okay, it's definitely solid. But this one doesn't have or equal to, so it's dashed. And it says x is greater than 4, so I am interested in all of the x values that are larger than 4. So this time it's not looking at the y-axis, you're looking at the x-axis. So where are all the x numbers that are bigger than 4? Well, that's off to the right. So we're shading off to the right this time. So we'll shade over here. And there it is. That's what my graph would look like. All right, I'm Mr. Borg, and that was linear inequalities. I think I'll do another video about linear inequalities in word problems, and then graphing them and seeing what the results look like, because they're pretty interested, but it'll probably make this video a little bit too long if I kind of included that at the end. All right, so that was linear inequalities. Hope you enjoyed.